Today we are gonna talk about Eolian desert system. Here, Eolian means wind, and in the desert, the dominant depositional process is Eolian deposition. And again, the evaporation process is very strong because the precipitation in desert area is really low. So, how desert formed? This is a map. This is a global map. So we all know that if precipitation happens, that is water vapor in the atmosphere condensate becomes rain, becomes liquid phase, which is rain, and then precipitate on the Earth's surface. So when water vapor becomes a liquid phase, it needs temperature to decrease. And when the water vapor in the air temperature decrease, air motion need to be upward. So going up, the temperature decrease, and then water vapor becomes liquid raindrops. If we look at this global map, the hottest place is near the equator. So near the equator, the surface air is very hot, and the hot air tend to go upward. Therefore, the near the equator, there's a lot of tropical rainforest. And we know near the tropics, the precipitation amount is very high. And that's because this area is hot, and then air tend to move upward and produce rains. And when the air goes upward, it needs to go, it cannot keep going up. It needs to go somewhere else. So then when air transported to higher level in the atmosphere, it transports to north and south direction. And when it's transported to the north, when the latitude decreases, temperature decreases again, and the air parcel cools down and becomes a cold air. And the cold air gonna tend to sink back to the Earth's surface, and this air gonna be warm up again. So when globally, when this air rise from the tropics and move upward to around 30 latitude degree north and south, that's the time the air becomes cold and start sinking downward. So and the air gonna warm up. And remember, this air parcel has already produced the rain near the tropics, and now when the air sinks down, it is dry air, and when it sinks down, the air becomes temperature increase and does not produce any rain. So and globally, near 30 degree north and south in latitude, the air motion is dominated by downward motion. Vertical motion is dominated by downward motion, and it's a dry air. So the desert environment globally tend to develop near 30 degree north and south of the equator. So if we only consider atmosphere circulation, then the desert are supposed to develop only near north and south degree in latitude on the Earth. However, in here, we also see the desert develop in other latitude locations globally on the Earth. That is because continent location, the area of the continent, and the mountains gonna change the atmosphere circulation. So, in the North America, climate model and the simulation has shown evidence that because of the uplift of the Rocky Mountain in the western U.S., the Great Plains in the western U.S., this area start to dry. and this is because of the Rocky Mountain has changed the air circulation in this region, and makes this area becomes drier. Therefore, we can see the desert develop here in the 50 degree in latitude, and lower places as lower here in Mexico as well. And a similar mechanism happened in the South America because of the uplift of the Andes. Then in the rain shadow of the Andes, this area becomes a desert as well. And similar in Asia, uplift of the Tibetan plateau influenced the inland Asia climate, and makes this area becomes very dry because the Tibetan plateau has blocked all the moisture from Indian Ocean to inland. And for the West Africa desert is developed because this zone is dominated by trade wind. Trade wind is from the northeast direction blow to the southwest direction, and then it is from the continent. This wind that's dominated, and so the wind gonna blow from the continent to the sea, and blocks the moisture from the sea to the continent, and therefore this West Africa area becomes really dry. So therefore, the global atmosphere circulation and the topography gonna influence the formation of desert. Desert development also requires a little vegetation, and therefore Antarctica and Siberia also has a desert developed because their vegetation cover is low, and that area is very cold, and when air is cold, the water content in the air becomes really low. Therefore, the precipitation is low. And that's how the desert developed in those areas. Okay, Eolian deposition is like fluvial deposition. The sediments includes fine-grained suspended load and relatively large-grained bed load. In this situation, is the sediments that travels near the ground. As you can see, similar to the fluvial deposition process, the sands sediment travels in saltation and attraction motions near the land surface, while suspended load dust and lurs, they travel up in the air and can travel for thousands miles. So these are pictures of lurs up in the air. And these pictures are showing the East Asia or East China area. Where I am from, I have seen weather like this. So, and these lures, they travel from West China and the Mongolia area all the way to East Asia, to Japan, to Korea, to Hawaii, and even the people who study dust in America, they found that those lures actually transported from Asia. So lures can transport for a long distance. The same in Australia, the inland west part of Australia, the desert provides lures and transported to the east of Australia. So sand deposit, the depositional structure, the dominant depositional structure is dunes. One thing I want to clarify is that lurs is the term for wind-transported mud-sized particles, and when it is rain-transported, it has a characteristic is that the sorting of the particles is really well. So I always say when we talk about mudstone, we don't really talk about the sortings. However, to identify if the deposit, the fine grain mud deposit, is a Lurs deposit, it's a Eolian deposit, then we usually use the sorting of the grain size to diagnose if it is a Eolian deposit. So because the wind transport particles, the energy is very critical, and only certain grain size can be transported. So therefore, the Eolian deposition has very well sorting. The next is the sand deposition of Eolian processes. Then in Eolian process, the sand deposit is also very well sorted, and usually the sand developed in stratification beddings. So the dunes, sand dunes, the depositional process is similar to fluvial depositional process. Instead of ripples, most of the time it developed large-scale sand dunes, and the stratification, the crossbed stratification, the crossbed angles is relatively high, and that's the large-scale dunes. And also in Eolian deposit, it sometimes is also develop ripples and low angle stratification and laminations. So these are some pictures in the geologic record, from the geologic record in outcrops. We can see that's the large-scale stratification beds, and it is definitely the angle is higher than fluvial deposit, and the large scale you can see. Another thing is the wind deposit. Even though the wind deposit has a very well sorting, but the wind speed gonna change. So within the stratifications, within one of the stratification, we can see laminations within the stratification in the micro scale. And this is one episode of deposition, another episode of deposition, and here is alternating, and we can tell that the particle size here is small and the particle size here is large, then the wind speed over here gonna be slow, and the wind speed here gonna be relatively fast. So what I'm trying to say is that even though of Eolian deposition produce very well sorting sediments, but within geologic record, the wind transportation velocity transportation velocity varies, and the grain size within the rock could vary. To identify this is a Eolian deposition sandstone. Number one, the high angle cross stratification beds. That's one of the diagnostic structures. And another evidence is that even though the overall grain size sorting is not very good, but within one, all the deposition could all the microstructures within the rock has laminations, and in each lamination, the grain size sorting is very well. And in desert, the dunes are in different morphologies. Here, we're not going to talk about it in detail, but in general, we know that the wind direction gonna change throughout the years in different seasons, and that makes the dunes the dunes in different morphology can superimpose on each other, and makes the complicated dunes morphology. So I'm not going to talk about this in detail, but just let you know the dunes morphology can be complicated, and that's due to that's because of the wind directions could change through time and during the year. Okay, So for Eolian depositional system, so what you need to know is that how does a desert form on Earth, and then what's the characteristics of Eolian sediments